All right, today we got to talk about fractions. We're going to be doing lots of fractions in class. So let's review some of our very important fraction skills from before. So first off, we have to be able to reduce, right? All fractions need to be in lowest terms. Makes it a lot easier to work with when they're reduced. So if I have something, I don't know, maybe 12 over 24. That's a nice straightforward one. We know that 12 goes into itself once. We know 12 goes into 24 two times, and there you go, we found our answer. So our answer is 1 over 2. Let's try another one. Let's say the fraction of maybe 15 over 20. Okay, so again, what goes into 15 and 20 evenly? 5. 15 divided by 5 is 3. 20, divided by 5 is 4. So there's our answer. 15 over 20 reduces to 3 over 4. Okay, what about if we have letters in there? So if I have any letter over top of itself and it's exactly the same, it's the same as if I have the number over the number. So x goes into itself once, x goes into this x once, and we're left with 1. Okay, what if I have, say, x squared y to the 4 divided by xy to the 5? Oh, we got a few more things going on in here. Remember, if there's no exponent, it's a 1. And remember that when we have exponents and we are dividing them, we need to subtract our exponents. So if I have 2 of them up here and 1 of them down there, then I've got my x is going to be 2 minus 1. And I've got my y's. So I've got a y, it's got 4 up top, 5 down below. So that's going to simplify to x to the 1, y to the negative 1. Oh, we don't want negative exponents. So we have to bring back in that other rule where anything to the exponent negative 1 is going to be equal to 1 over itself. That could be a negative 4, so that would be x over 4. So anything to the negative exponent gets written as 1 over the same thing to the positive exponent. And we could see that if we had canceled, so hang on here. So this becomes, well, x has the positive 1 up top and y has the negative, so it goes down below. So I could look at this as, let's see, I've got x squared y to the 4. I'm just going to write it again. xy to the 5th. I could expand all that out. So let's expand all that out. X squared means I've got 2 of them. Y to the 4 means I've got 1, 2, 3, 4 of them. Let's look at down below here. I've got 1x and I've got 5 y's. 1, 2, 3, 4, 5. And then the same thing with canceling. If I see 1 of them up top, I take out 1 on the bottom. How many do I have left? 1. Okay, same thing for the y's. I've got 1y, 1y. And then I've got this y and this y. And then I've got this y and this y. And I've got this y and this y. Oh, and I'm out of y's to cancel up top. How many do I have left at the bottom? I have 1. So I can think of it in terms of the canceling like that. I can use my rule. Either one works. Okay, so there's reducing. How about if we multiply or divide fractions? Let's look at multiplying. Multiply. A, B, C, D, E. All right, let's do 1/3 times 4 over 8. No, not 4 over 8. Let's do 4 over 7. Okay, so the rule with multiplying fractions says that it's your numerators that multiply and your denominators that multiply. Look to see if anything cancels. In this case, it doesn't. So I now have 4 over 21. Let's look at one that cancels. So what if I had 2x over 5 times 15 over, let's go with 8. Sure, I threw an x in there, but I don't have any other x's to worry about, so okay, that's fine. Do I have any that cancels? Oh, 2 goes into 8, so 2 goes into itself once, 8 4 times. Oh, and 5 goes into 15. 5 goes into itself once. 15 3 times. So my question boils down to 1x times 3 divided by, let's see, I got 1 times 4. So this would simplify to 3x over 4. All right. What about if I'm dividing? Let's divide. E, F, G. So dividing is the same idea as multiplying. We just have to add that extra step in front. So that's like if I have, I don't know, 5 over 12 divided by 9 over 3. No, I don't want over 3. Over 4. So the first thing we have to do with that one is, let's see, we're going to keep the first fraction, change the divide to a multiply, and then we've got to flip the second fraction because when we're dividing, we're really multiplying by the reciprocal. See, do we cancel? Oh, 4 goes into itself once and 12 3 times. That's all we can cancel. So that means I have 5 times 1 in my numerator and 3 times 9 in my denominator. So that leaves me with 5 over 27. What happens if I want to take 1/2 and I want to divide it by a whole number? Oh. Well, don't forget, every whole number is the same thing as is itself over 1. So I can turn it into a fraction. And then let's do our dividing skill. So we keep the first one. Divide becomes a multiply. Flip the fraction. And then you multiply your numerators. Multiply your denominators. And you're left with 1 over 6. What if I throw some fractions in there? Or some, these are fractions. What if I throw some letters in there? Ooh, variables. Let's go with xy squared over 25. Divided by, oh, let's go with x cubed y to the 5 divided by 3. Sure. Same rules. Keep the first one. So xy squared over 25. Change that to a multiply. Flip your fraction. 3 over x cubed y. Oops. Y to the 5. All right. So when we're multiplying, remember we're multiplying all our numerators. So I'm just going to put it in the same order as each other. So I'm going to put my number in front. And then I'm going to do my x, and then I'm going to do my y squared. So I'm just going to organize myself here. Number in front, then my x, then my y, and then it's nice and easy to see who can reduce with who. Does 3 go into 25? Nope. So that stays. Can't reduce those. I have 1x here, so there's 1x there, and I got 3 in the bottom. So x goes into itself once, x goes into, so then let's subtract that. So I got 2 left on the bottom. So no more x's up top, but I have 2 x's down below. And then I've got, let's see, 2 y's up top and 5 of them down below. So they'll cancel out. And I've got y to the 3 on the bottom. So there's lots of ways to look at these letters when we're canceling them. So when I was canceling my x's, let's see, I'm just going to do it over here. X to the 1 over x to the 3. I can use the rule. So that gives me x to the 1 minus 3. So that's x to the negative 2. And then use the rule that a negative exponent is now down in the denominator. I can do the same thing with my y's. So I've got y squared up top, and I had y to the 5 down below. So I'm going to subtract my exponents because I'm dividing. That gives me y to the negative 3. Negative means it's down below. Well, it means it trades places. So instead of being up top in a numerator, it's now in a denominator. And there you go. So you're done. Sound good? Okay, good. So that's, let's see, what did we do? We did reducing. We did multiplying. We did dividing. Now let's do some adding and subtracting. So adding and subtracting is where we need the common denominator. Add and subtract. These ones are your common denominator. Okay, very important. Let's start simple. What letter are we on here? That was I, so we're on to J. Common denominator. Start simple. 1/2 plus 3/4. Sure. We know 2 times 2 gives me 4, so we're going to multiply top and bottom. So this first fraction becomes 2 times 1 is 2, 2 times 2 is 4. So I didn't change the number, I just wrote it differently, because remember I can reduce, right? 2 divided by 2 is 1, 4 divided by 2 is 2. Okay, I need them both the same. So then my numerators add up, and they're all over the same denominator. 2 plus 3 is 5, so I end up with 5/4. Now, quite often in the past, you also had to turn it into a mixed number, so 4 goes into 5 1 times with 1 left over. Okay, with polynomials, we're not really going to bother with that step because this is going to be completed enough for us. J, K. What about if I have something like, I don't know, 3/5 minus 2/7? Sure. So this time there's no common in between the 7 and the 5. So this time, if this is a 5, I got to multiply the other one, top and bottom, by 5. And if this is a 7, I got to multiply top and bottom on the other one by 7. Let's see, 7 times 3 is 21. 7 times 5 is 35. Minus 2 times 5 is 10. And 7 times 5 is 35. Now I have my common denominator. Now I can subtract my numerators. We're just subtracting our numerators. And then we put it over the same denominator. 21 minus 10 is 11. And we're done. J, K, L. What if, oh, let's put some letters in there. Let's say, I don't know, 8/x² plus 3/xy. All right. Looking at our denominators here. I've got 2 x's there, right? Maybe we'll write this out so it's more obvious. X² means x times x. And I'm plussing that with 3/xy. All right. We'll take out the magic here. So I've got 2 x's there, so I need another one to multiply over here. So I've got to multiply top and bottom here by x. This one's got a y, so I need a y over here. So I've got to multiply top and bottom by y. So now what we have, let's see, I now have an 8y up top. I have my x² y on the bottom, plus 3x up top, x² y on the bottom. So now my denominators match. Add my numerators, so you got 8y plus 3x all over x² y. Can I go any further? No, you are done right there. Okay, so try your practice questions, see where you get, and let me know where you need help with.